Hey guys, in this video we're going to look at some basic examples of antiderivatives and indefinite integrals. If you don't know the difference between those two things, I actually broke this down in another video. I will drop a link to that in the comments. And I'd highly recommend for this video that you pause and try the examples on your own and then check them with the video. That would just be a lot more meaningful. So to start, we're going to start by just finding the antiderivative of a couple of functions. And so to get warmed up here, we're going to be using this antiderivative formula. Now, if you don't have these written down, you might want to take a moment to do that. This can take your brain just a little bit of time to figure out antiderivatives. I actually tend to do this now without formulas, but it took me a little while to get there. At some point it kind of clicks and it starts to make sense, but it'll take you a little bit to get there. So to find the antiderivative, so I'm just going to be given a function, and so the form of my antiderivative will be f of x equals, and now basically what I have to do is figure out what is the structure of a function that would get me to this as the derivative. Now, I think it's helpful to rewrite this in this exponential form. So the thing that you might want to think about, and the thing that you have to wrap your head around, so when you're finding the antiderivative, you're actually adding 1 to the exponent, right? So we're unraveling, kind of going backwards on that derivative. So I need to add 1 here. And then I also have to figure out what constant I would have to put here to get to the form of my derivative. So this is a little bit of playing back and forth in your head. So in this case, the first thing I usually think about when I do this, I first add 1 to the exponent. So this would give me -1. So if I take the derivative of this right now, this would end up with something negative, right? Because if you just think about what is here's kind of the way I think about this. So I would have, if I took the derivative of this, I would bring down that -1, and then I would subtract 1 from the exponent. So this is not quite right. So then that tells me that I need to put a negative right here, because if I put a negative there, then, let me erase this, then by taking the derivative of this, this will be -1 times this negative, and that will give me x to the -2nd. Now I'm still not done, right? So the other part of your antiderivatives, they always have to have the plus c. So you always want to make sure that you do that at the end. So, like I said, this can take just a little bit of time to figure out, and people use different approaches. A lot of people will kind of use this structure of the antiderivative to get started. I have a tendency to kind of just think back and forth of, what happens if I take the derivative, but not everybody's like me. So if you want to have the formula in front of you, maybe write this down. Okay, so what I want to recommend is that you actually pause the video and try these 3. Hit play when you're ready to see the solution. Okay, so for this first one, so the antiderivative here, well, this is just going to be, so if I use the formula, maybe I'll go that way. So if I use the formula, it's going to be 1 over n plus 1 and then n plus 1 here. So here's my n, right? So what that would mean then if I'm following the formula, so I'd have 1 over 2 plus 1 times 3 times x to the 2 plus 1. So there's like what the formula is telling me. But again, the way I kind of think about this, I first just think about what would I have to do to the exponent. So I know that I would get x to the 3rd, and then I can just see by taking the derivative of this, I would get back to the antiderivative. And then in both cases, you still need that plus c. So you never want to forget about that part. So there's the antiderivative there. Now for this one, so let's see, going on to the next one. So I think about this as first I add 1 to my exponent, and then I have to figure out what would I have to kind of put in front of this so that when I take the derivative, I actually do not have any constant here. So that would be a 2. A 2 would go here, and then this would be plus c. And again, if you were to actually use the formula here, you would get to the same thing. So it's just 6 one way, half a dozen the other. So this would give you, I guess if you just want to see what that would look like, so this would become 1 over 1/2 times x to the 1/2. That would be what the formula would give you. And then of course, when you unravel this, you get the 2 up here. So you do you, whatever helps you kind of get through this. Okay, so for this last one, so once again, if I think about just first adding 1 to the exponent, this would give me the positive 2/3. So I actually don't need to worry about putting anything in front here, because then when I take the derivative of this, I will just naturally get to this. So then I just need to add my plus c. Okay, so there's the first part. So that's just kind of a little bit of a warm up for us. So now I want to pivot from antiderivatives to indefinite integrals. Again, if you have no idea what the difference is, they're kind of like the same thing, but if you want just a formal breakdown of them, again, there's a really quick just explanation of that in the description. Okay, so now for this one, so I'm going to need kind of these formulas here. Actually, let me just show you them. And if you need to write them down, pause the video. So I'm going to need these formulas, and then we're going to be moving just into all trig integrals here. So here's another list of all the other trig integrals. So write down what you need. It can be really handy to have this all in front of you. Okay, so now for this one, if I'm trying to find the indefinite integral, so this is just going to be -2 cosine of x plus c. So this constant in front's not really going to do anything, right? So if I just take the derivative of this, so the derivative of cosine is negative sine. So there's obviously got to be a negative in front of here so that this ends up positive, and then of course the plus c. So that I can get again from kind of referencing this formula, but you know, on the other hand, if you just kind of think about what you know about derivatives, you can kind of unravel it and think about what makes sense and what kind of adjustments you have to make. Okay, so why don't you pause the video again? Try these. Actually, if you want to see the list of antiderivatives one more time, I'll just show you in case you want to pause and write them down. There's that, and there's that. So you're going to need to use those then to figure out these indefinite integrals. Hit play when you're ready to see the solutions. So for this first one, this one's just going to be really nice and straightforward. So this is the tangent of x plus c. That's it. And then for this one, so this will be, so the antiderivative of cosine is just sine, and this will just be sine of pi over 2 plus c. So think about, oh, sorry, pi over 2x, my bad. Pi over 2x plus c. So just think about when you try to take the derivative of this, so you know you have to use the chain rule. So you would take the outside derivative, which would be cosine of pi over 2, but then you'd multiply that by the derivative of the inside function, this part here, so that would just be times pi over 2, so then I would get to this. So that's the solution there. Okay, now for this last one, so now, let's see, this is going to be 1 over 3 cosecant of 3x plus c. So now in this case, right, there's no number in front here, so that tells me when I took the derivative of this that the constant fell out. So you've got to have the 1/3 in front here. Again, you'll use that chain rule when you multiply by the derivative of 3x, which is just 3. This will all drop out. So that'll be your antiderivative. Okay, so those are some trig ones. So we're going to move on and just try a couple others that are in the list. And hey, just if you're finding this helpful, consider liking my video or subscribing to my channel or leaving me a comment. That just really helps support me continue to make videos like this. So your support really helps. Okay, so now I've got this last list. So let me show you just a few more handy formulas. Again, pause the video if you need them. So here's the first list. Write down, you know, all of these if you need them. And then here's the other list. Again, write them down. So this will all be really handy. So this list is what you're going to use to get these done. So pause the video, hit play when you're ready to see the solution. Okay, so for this first one, so this will be -1 over 2 e to the -2x plus c. So again, so you know the derivative of just e to the -2x will be itself times the derivative of the inside, which is -2. Since this has no constant in front, that tells you that it must have dropped out when you took the derivative, so this would be the only way you could set that up. Or, again, you can just use the structure of the antiderivative and you get to the same thing. So here we had a -2, so then I wrote -1 over 2, so it literally comes out to be the same thing. So it just takes a little while to figure out what is the right way for you to do this for yourself. Okay, so for this one, so I've got this constant 2. Nothing really needs to happen to that. There's no number under here, no k or anything. So this is going to equal 2 inverse sine of x plus c, and that's it. And then for this last one, so this is now just straight up using the formula. So this is 1 over the natural log of 3 times 3x plus c, and so that would be the antiderivative of that one. And so that really covers it. So thanks for watching this video. Again, consider giving me a like. I have more videos on antiderivatives and differential equations and kind of everything that you just need to know about this. So hopefully I'll see you in another one. Thanks.